3.2 are properties of parallel lines. So we're still going to be working with two lines and a transversal, but now the two lines are going to be parallel. So our goal today is going to be to identify conjectures of parallel lines in a transversal. So you'll notice that the very first conjecture we're going to talk about is a postulate. What's a postulate again? What was the definition of a postulate? It's not something proven. What is it? Did you say something? Oh. Go ahead. Yes, it is. A postulate is something that's obviously true. We don't have to prove that one because it's so obvious. Okay? Now, anything that is a theorem, those have to be proven. And you can use postulates to prove them. You can use definitions to prove them. You can use our property of equalities to prove them. You can use previous theorems that are already been proven to prove them. But the first one that we're going to learn here is the corresponding angles postulate. And it says if a transversal intersects two parallel lines. So now we're not only dealing with two lines, it's not a transversal intersects two lines. Those two lines are going to be parallel. Okay? Then corresponding angles are going to be what? And if you look down here, if you think about two angles that are corresponding, like angle 1 and angle 5, and these two lines are parallel, if you were to slide this intersection right down here, 1 would completely overlap 5. Angle 1 would be completely overlapping 5. They would be the exact same size. What does it mean if 1 overlapped 5 and they were the exact same size? They're congruent. So if we have corresponding angles postulate, what that says is it says if a transversal intersects two parallel lines, it will make corresponding angles that are congruent. So since 1 and 5 are corresponding and 1 is congruent to 5 here, we know that because M and N are parallel. See how they're marked parallel here? See the parallel marks? That extra mark means that they are parallel. Okay, so that extra arrow are parallel marks. That's showing that those two lines are parallel. Okay, if 1 is congruent to 5, what else in my diagram could I mark congruent? Okay, but I'm going to have to use something different, so I'm going to use two arcs here. I'll say that 2 and 6 are also congruent because those are also corresponding angles. What if I don't even look at this bottom intersection? What if I just look at this top one? What do you know about angles 1 and 3? Why are they the same? The vertical angles theorem says that 1 and 3 are vertical angles, and since they're vertical angles, the measure has to be the same. So we said since 1 and 3 are vertical angles, they must have equal measures, which means they must be congruent. So I'm going to mark 1 and 3 actually congruent. So 1 and 3 have to have the same measures. What else do you know in that top intersection here? 2 and 4 have to be what? Congruent, because those are also vertical angles. So 4 will have the double arcs, because 4 is going to be congruent to 2. Okay, so then what about 7 and 8? Because those are the only things that don't have labels on them right now. 7 is going to be what? 7 has to be congruent to 5, so that's going to have a 1 arc on it. And what about 8? It's going to be what? It's congruent to 6 because those are vertical angles, so it has to have 2 arcs on that one. Okay? So then let's look at this, because that is how you would do a proof, is you would have to use, these are corresponding angles, and then because of vertical angles theorem, this is congruent to that, because of vertical, so you would use those steps that we literally just did, but out loud. We would just write those steps down, and that's how we would prove these next couple theorems that we are coming up with. This theorem says the alternate interior angles theorem. Well, let's identify some alternate interior angles down here. Give me a pair of alternate interior angles from this diagram. 3 and 5 are alternate interior angles. What do you notice about 3 and 5? They're congruent. So alternate interior angles theorem says that if a transversal intersects 2 parallel lines, then the alternate interior angles are going to be congruent. Okay, let's look at alternate exterior angles. What are 2 angles here that are a pair that are alternate exterior angles? 2 and 7 are same side. 2 and 7, see how they're on the same side of this transversal? We're looking for alternate exterior angles. 2 and 8 then. 2 and 8 are on opposite sides of the transversal and they're exterior angles. Angle 2 and 8 are alternate exterior angles. What do you notice about their measures? They have to be the same. So 2 and 8 are also congruent angles because we marked them congruent. Do you see that? So it says, if a transversal intersects 2 parallel lines, then alternate exterior angles are, we just showed how they are congruent. Same side interior angles theorem. What are same side interior angles? Give me a pair. 3 and 6 would be the same side interior angles. Are those congruent? No, they're not. But let's try to come up with a relationship that we know that they have. Who said supplementary? Why? How do you know? Because why? You are right. They are supplementary. But let's look at something that we know. 1 and 2 are what kind of angles? A linear pair. What do you know about linear pairs? Linear pairs, if 2 angles form a linear pair, then they are supplementary. Remember that linear pair theorem? Okay. So the 1 arc and a double arc have to be 2 angles that are supplementary. So when we're looking at our same side interior angles, 3 and 6, see how one of them have a 1 arc and the other has a double arc? See how these same side interiors, 4 and 5, one has a single arc, the other has a double arc? A 1 arc and a double arc are going to be add up to 180 because they're supplementary here. So a 1 arc and a double arc will also add to 180 in that part of our diagram. So these 2 angles must be supplementary. If we have parallel lines, if a transversal intersects 2 parallel lines, then the same side interior angles are supplementary. The same side exterior angles theorem says if a transversal intersects 2 parallel lines, then the same side exterior angles are, what's a pair of same side exterior angles here? 1 and 8 are same side exterior angles. 1 and 8 have what kind of relationship? They're also supplementary because one's a single arc, the other one's a double arc. And we know that those are supplementary. Okay. So now that we have all these theorems and our one postulate, we're going to use these to find angle measure. Sorry, excuse me. We're going to find these to find angle measurements. So in this, it says find the angle measures, and it gives us that the measure of angle 2 is 35 degrees. So I'm going to label the measure of angle 2 is 35 degrees. I always find it much easier if I label right in my diagram. Okay? Now, I'm going to pretend that this one's not here because I know how to label the 4 angles around 2 intersecting lines because I know about vertical angles and I know about linear pairs. What does the measure of angle 1 have to be if this one's 35? 145 degrees. Why? The linear pair theorem says they have to be supplementary. We need to make that an angle so that the 2 angles add to 180. What does the measure of angle 4 have to be? 35. Why? It's a vertical angle or it's supplementary to the 145. I don't care which way you think about it. What does the measure of angle 3 have to be? 145. Because that's a vertical angle. Remember last week I told you that vertical angle theorem and the linear pair theorem are going to be used almost every single day? Look at that. We're already using them today. I wasn't lying to you. Okay? All right, now that we have those 4, you could use corresponding angles. You could use any of those theorems that we just learned to identify the angle measures for 5, 6, 7, and 8. What does 5 have to be? 145. That's a single arc, so look at your single arcs up here. This one would be 145. This single arc would also be 145. What are the double arcs going to be? The 35. Then I'm going to go over, I'm actually going to label them over here where it says, I'm going to look, I labeled 1 145 degrees. I labeled 3 145 degrees. I labeled 4 35 degrees. I labeled 5 145 degrees. I labeled 6 35 degrees. 7 is labeled 145. And 8 is labeled 35 degrees. So I use my diagram to find. So we use those labels to find all these angle measures and mark them. All right, example 2. Example 2. This here is another way that we can identify parallel lines. So we're marking that those are parallel, and then these are also marked parallel. So this is one where we have multiple transversals. So cover it up. And let's just focus on this one. And what can we label based on this transversal right here? And if you give me something, you have to be able to say because. Go ahead.
Angle 2 is also 105
Because the lines are parallel, and what kind of angles are those? They are congruent, but why? What type of angles? What's their relationship? Those are corresponding angles. So I can say that these are 105 degrees because the lines are parallel, so corresponding angles are congruent. That's what I would say. These are corresponding angles, so they are congruent. What's next? What else can you label? Go ahead. Yes. Angle 1 is going to also be 105 degrees because of the vertical angles theorem. Those are vertical angles. Vertical angles must be congruent. What else can you label? Go ahead.
Angle 3 would be 105 degrees.
Which ones are corresponding? Yes, 1 and 3 are corresponding angles, and since the lines are parallel, 3 and 1 have to then be congruent. So you could have also said that 3 and 2 are vertical angles. You could have used that relationship. Either way, you're going to get 105, but when you're asked to explain, that's how you're going to explain. You can use any of those explanations would work. All right, let's cover up a different half. We'll cover up this bottom half. And we'll look at just that top transversal. And what can you tell me about 6 or 7 there? You can give me 6 or 7, either one. Why would 7 have to be 105? Those are not corresponding. Oh, to what one? 1 to 7 are corresponding angles, yes. And corresponding angles must be congruent, so it has to be 105. Yes, that will work. I thought we were talking about the 105 that was given. All right, what else? 6 has to be supplementary to what? To 7, because why? Because why? But there's a better phrase for it than it makes a line. We have an actual theorem. The linear pair theorem. 6 and 7 are a linear pair, so linear pairs must be supplementary. So what does angle 6 have to be if it's supplementary to 7? 75 degrees. All right, we have both of those, so cover up another part. To get 4 and 5, you could cover up this right half or you could cover up the top half. It doesn't matter. So maybe I'll cover up the top half. We'll try it this way. Go ahead.
5 has to be 105 because 2 and 5 are corresponding angles.
Perfect. 5 has to be 105 because 2 and 5 are corresponding angles. Corresponding angles postulate says that they must be congruent because we have parallel lines. What else? How about that number 4? That's the only one we have left. Go ahead.
6 and 4 are corresponding angles.
Oh, okay, so you want to cover up this half. Perfect. And then 6 and 4 are corresponding, so 4 has to be what?
75.
Perfect, 75 degrees. That will work. All right, let's go ahead and record these. The measure of angle 1 was 105 degrees. The measure of angle 2 was 105 degrees. The measure of angle 3 was 105 degrees. 4 was 75 degrees. 5 was 105 degrees. 6 was 75 degrees. 7 was 105 degrees. Just all from what we already labeled in our diagram. It's much easier if you label in your diagram first. That's your showing of your work, is labeling in your diagram, making marks in your diagram. You'll find that a lot this year. We'll label directly in a diagram and then come back and put our answers in. Okay. Are we ready for the back side? All right. The next example says that we have to find x. If the measure of angle 3, I'm going to label it right here, the measure of angle 3 is 12x minus 8. And the measure of angle 5 is 3x plus 10. Okay, I can see that these are marked parallel. So what I'm going to have to do is I'm going to have to identify what kind of angles are 3 and 5. They're alternate interior angles. Okay? So if I have parallel lines, then I'm going to abbreviate alternate interior angles. And we'll go back and put all of our abbreviations in because we forgot to do that. AIA is alternate interior angles are what? What's that postulate or theorem say? If parallel, the alternate interior angles are what? Angles are not equal. Angle measures are equal, but if I'm talking about angles, they are what? Congruent. Okay, so that means that angle 3 has to be congruent to angle 5. If angles are congruent, then the measure of angle 3 has to equal the measure of angle 5. And I know that the measure of angle 3 is 12x minus 8. And 5 is 3x plus 10. So I set those equal to each other. Now we just have algebra to do. So let's solve this. What am I going to do in order to get x alone? Subtract 3x from both sides. Remember, if I had to justify with reasoning, I would not necessarily write in this step, and if I did, it wouldn't have a reason to it. 12 minus 3 is 9x minus 8 equals 10. And then I would write my reason here would be subtraction, property of equality. I know I'm not usually supposed to abbreviate, but subtraction, property of equality. Because I don't want to get that confused with substitution. But that's subtraction, property of equality. Then what? Add what to both sides? Add 8 to both sides. Remember, that does not get a reasoning because I don't necessarily have to write in that step. But I get 9x equals 18, and that's where I write the addition, property of equality. Then what comes next? Divide by 9. Remember when I write that in? So that doesn't have a reasoning, but our step what we get when we divide by 9 would then be the division, property of equality. Okay. So that's x equals 2. So we found x. That's what we were supposed to do. It's also a really good idea to plug x back in and make sure your answers make sense. If I plug in right here, 3 times 2 plus 10, 3 times 2 is 6. 6 plus 10 is 16 degrees for angle 5. If I plug it in here, 12 times 2 is 24. 24 minus 8 is also 16 degrees. Does it make sense if 5 and 3 are both 16 degrees? Yes, they were supposed to be congruent. They were supposed to have equal measures, right? So we're good. All right, we have 2 proofs that we are going to do together. Given that A is parallel to B. Now, we're trying to prove that 1 and 2 are supplementary. Okay? This is actually proving one of our theorems. It's proving the same side interior angles theorem. Because the same side interior angles theorem says that if 2 lines are parallel, then same side interior angles are supplementary. So if A and P are parallel, then we'll have angles that are supplementary. So, given A is parallel to B, A is parallel to B, what's our reason? Given. Look at given. It gives us the reason. When we are actually doing a proof. Now remember, I have not asked you guys to do any proofs on your own yet. I've had you do a couple cookie cutter proofs, but I have not had you guys do any proofs completely on your own. I've had you solve problems where you have to justify your reasoning as if kind of like we were working through a proof, but I did not make you do the whole setup and everything. Okay? That was given because it went with given. Measure of angle 2 plus the measure of angle 3 is equal to 180. Why is it that 2 and 3 have to add to 180? The linear pair theorem. So the linear pair theorem tells you that 2 and 3 have to add to 180. Those are a linear pair. They must add to 180. Okay? We can use the linear pair theorem because we've already proven it. We proved that last unit. So it's allowed to go in a proof. Why is angle 3 congruent to angle 1? Remember, we're only allowed to use postulates, theorems we've already proven, or definitions. Go ahead.
Corresponding angles postulate.
Yes, that is the corresponding angles postulate. You can abbreviate corresponding angles as CA, and I told you that when we're done here, we'll go back and write in those abbreviations because we haven't talked about them yet. Corresponding angles postulate. Okay, now we have to try to figure out why is 2 and 1, why do they add to 180? Now, we can see that that's where I was eventually trying to get to, but we can't just say 2 and 1 add to 180. It must come from these previous steps. So how did they get that 2 and 3 add to 180? And now they get 2 and 1 add to 180. What happened there? Substitution. They substituted 3. 3 is the same as 1, and they plugged in 1 there instead. You see that? So they use substitution to say that the measure of angle 2 plus the measure of angle 1 has to be 180 because 3 and 1 are congruent. And if 3 and 1 are congruent, then they have equal measures. Okay? So, how then is, if 2 plus 1 is 180, how is it that 1 is supplementary to angle 2? Why is it that if the measure of angle 2 plus the measure of angle 1 equals 180, that we can say 1 and 2 are then supplementary? I can't use same side interior angles theorem because that's what I'm trying to prove here. So we're not going to see that in our proof if that's what we're proving. So we're not going to use a same side interior angles theorem. They are same side interior angles, but that's what I'm trying to prove. But why is it if 2 angles add to 180, then they are supplementary? What tells me if 2 angles add to 180, then they are supplementary? The definition of supplementary. Yeah, the definition of supplementary. What'd you say, oh shoot, for? It was easy. Oh. So the definition of supplementary, remember you can use postulates, you can use definitions, you can use our properties of equalities, you can use theorems if we've already proven them. But if you're in the process of proving it, you cannot use that theorem in there. Okay? All right, let's try the next one. We're given that A is parallel to B. We're trying to prove that 1 and 3 from our diagram are congruent. That means we're probably trying to prove what kind of angles are those? What kind of pair? Alternate interior angles. That means we're trying to prove here the AIA theorem. Here we were proving the SSI theorem. And if we're proving those theorems, you'll never see AIA theorem in our reason, because that's what we're proving. Okay, but that is the theorem that we're right now proving. Okay, because all of these theorems that we've talked about have a proof. All right, so why is it that A is parallel to B? Given. Oh, good. All right. Angle 1 is congruent to angle 4. Why are 1 and 4 congruent? Yes, the corresponding angles postulate. And you'll notice that you have to use the corresponding angles postulate if you try to prove any of these theorems. Okay, that's how you go from one to the next. Okay, 1 and 4 are congruent. How do you know that 4 and 3 are congruent? Vertical angle theorem. All right. How do you know if 1 is the same as 4 and 4 is the same as 3, then 1 is the same as 3? Substitution, or in this case, you could also use transitive property. 1 is 4 and 4 goes to 3, then 1 goes to 3. Okay, so you could use transitive property here. Or actually, it's property of congruence, not property of equality. Or substitution. Either one would work. And there we prove the alternate interior angles theorem. Okay. Now, if I go back to the first page, we'll actually write in what those abbreviations are. Corresponding angles, we can abbreviate that CA. Alternate interior angles, we'll abbreviate that AIA. Alternate exterior angles, AEA. Same side interior is SSI. Same side exterior angles are SSE. And we'll use those abbreviations instead of having to write out same side exterior every single time. Now, we don't abbreviate when we talk. We don't say the AIA theorem. We'll say the alternate interior angles theorem, but you can abbreviate it when you write it down. Does that make sense? These are approved abbreviations for this class. Okey-doke. All right, the rest of the time is yours to work on both the 3-1 assignment if you did not finish that one, and the 3-2 assignment. You have to give some kind of reasoning when we're given the measure of angle 8. Here is 23 degrees. Find the measure of angle 1. How do you know? Okay, so giving your reasoning is just like what we did when we were talking through the notes. How did you label it? What did you say it was? You could tell me any of the corresponding angles with angle 1. You could tell me it's same side interior with such and such. Does that make sense? Okay, number 2 is one that has multiple transversals. So you're probably going to want to use your Post-it note so you can cover up half of your transversal. Or sorry, half of your diagram to only see one transversal. Whether that half is a bottom, top, left, or right, cover up half. Same idea goes for number 3. There are many transversals there, so be careful when you're looking at the parallel lines in the transversal. It might help if you highlight. You have a parallel line here, a parallel line here, and that would be your transversal. So that might help if you actually highlight the 2 parallel lines in the transversal. Because if you don't know if the lines are parallel, then those postulates and theorems we just learned, they don't mean anything because they all start with if you have 2 parallel lines, then these things happen. But if the lines aren't parallel, then the angles aren't congruent and supplementary. Does that make sense? So be careful here. And those were because, see the little extra triangles there? Those were parallel marks. Here are parallel marks. So you have to look for those parallel marks, and it might help if you highlight the 2 parallel lines. Here you can see parallel lines right here. Okay, then you have 2 different transversals there. So only look at one transversal at a time. That will help you. On the back side, you have your some algebra stuff. So if you're going to set them equal to each other, what's your reasoning? If you're going to set them supplementary so they add to 180, what's your reasoning? You just have to give me one of the theorems that we learned, whether it's AIA theorem, alternate interior angles theorem, corresponding angles postulate, alternate exterior angles theorem, whatever you end up, that's your justify, is the new theorem that we learned. So that's your setup. Does that make sense? All right, the rest of the time is yours.